Okay, so we're going over the final exam review for Unit L, which is all about limits. The first three questions here on this graph are about values of the functions. They're just to make sure that you understand the difference between the limit, which is what what the y value is approaching, and then the value of the function, which is what the actual value is. So if I look at f of 0, well, there's a hole there. So f of 0 is undefined. There is no value there. F of 2 is right here, and there's a point there at 0. And then f of 3, we notice that there's a hole at 1, there's a hole at 2, but the value of the function is going to be 3, the y value up there. Now the limit as x approaches 0 from the left, it looks like this is somewhat asymptotic. I can't really be sure. Maybe there's probably, it looks like there's an asymptote at -1 actually. On your exam, I'm not going to have anything this ambiguous. So it looks like there are actually two different functions here, right? Because if I'm just going to make a quick little asymptote here. Looks like this function is just like that, right? Maybe a little bit off. So that asymptote is definitely not at 0. So I'm just going to say that the limit does not exist. And I'll put a question mark there. It should be more obvious if there were an asymptote there. I copied this from some book or something. But the limit as x approaches 0, that definitely does not exist. Explanation point. And that does not exist because as we come in from the right, we're going to 2, and I don't know what's going on to the left. So when there is a limit, it has to be going to the same place from both sides. So notice for f, what's the limit as x approaches 3 from the right? Well, that's 2. But as x approaches 3 from the left, it's 1. So because they're not the same, yet again, the limit as x approaches 3 does not exist. Now, as x goes to -infinity, here we can definitely see there is a horizontal asymptote there. So that's going to be 1. And yeah. Okay, kind of a weird graph there. All right, so for the next one, the value of f of 0, there's a point there at 0, so we go 0. F of 2, as x approaches 2, well, from this graph, we can see there's a horizontal asymptote there, so this is going to be undefined. And then for f of 3, it again is 0. It crosses the x-axis at that point. Now the limit as x approaches -1, well, we can see that from the left we're going to positive infinity, from the right we're going to negative infinity, so this actually doesn't exist. The limit does not exist there. As x approaches 0 from the left, the limit is 0. As x approaches 0 from the right, the limit is 0, so this is 0. And then for f, same deal as d, it does not exist. And then as x approaches infinity, we can see that there's a horizontal asymptote there at 1. So these graphs were, I didn't really like these graphs. I'm going to get you one that's closer to the packet that we did in class for the textbook section 11.2? No, 11.1, sorry. Just that packet of graphs that we had. So your question on your final exam is going to be closer to that. Here we want to evaluate these using a table. So I'm not going to ask you explicitly on the final exam to use a table, but you're more than welcome to do so. If I just look at these, x squared minus 1, that's sort of a parabola. but then we are dividing by an absolute value here. And so because we're dividing by an absolute value, that means that the denominator is always going to be positive. So not only that, but well, we can see we're going to have that this is going to be x plus 1 over x minus 1 over x minus 1, the absolute value, right? So I just don't want to load up the calculator right now. Probably crash my computer. Think about us coming in from the left. As we go to 0, right, when x is 0, so when x is 0, the y function here, or the y value, is going to be -1 over +1, so that's going to be -1. We know that the at 1, well, we can cancel out the x minus 1s. Actually, no, we can't actually factor that, so that's undefined. Doesn't exist there. And then at x is 2, we're going to have 3 times 1, so 3 over 1, which is 3. So notice there's this big break here, and if we were to look and change our tables so that the table interval were even smaller, actually, I've been talking a whole bunch here. I'm just going to open up the calculator. Okay. All right, so I have my calculator here. And so what I'm going to do is I'm going to plug in here. This is going to be x squared minus 1. And we are going to divide by the absolute value. So to do that, we need to go to math and number. The absolute value of x minus 1. And so if we go to that table, we can see just what we saw, right, between -1 and 3. So if I actually go to table set, I can make sure that I start at 1 and then change this to something small like that. But now when I go to the table, look at where we're approaching. From the left, we're going to -2. From the right, we're going to +2. So that means that the limit does not exist. So I'll get rid of all this. So I really recommend you just use your calculators for those. And then bringing this back up, if we go to the second one here, you have another fraction. So be careful with how you put these fractions into your calculator. You certainly don't want to put you don't want to miss your parentheses, I should say. So, oh, I'm sorry, we're going to, as x approaches 3, and so again, we can make this a really small interval. So there we go. It looks like right between there is going to be 9, so this actually is approaching 9. For the next one, we have 3 over x, so 3 divided by x, whoops. And so whereas x approaches 0, It's looking at that small value. I must have done something. Oh, right. There's an asymptote there. Silly me. So look, as we go to the left, we're going down to negative infinity, but as we go up to the right, it's positive infinity. Graphically, this looks like this. So that, again, does not exist. And then we have the absolute value. The absolute value of x, or sorry, 2x. 2x divided by x. And so we're going to x is 0. So where are we going to? Oh boy, looks like, again, negative 2, positive 2. So again, does not exist. That absolute value is brutal. All right, I'm going to try and wrap this up here quick. So we just want to factor these, or you can use a table as well. So this factors to be x plus 5 times x minus 5. In the denominator, we are actually going to get x minus 5 times x plus 1. So the x minus 5s cancel out. So if I plug in my answer, I get 5. If I plug in 0, I get 5 over 1, which is going to be just 5. And then for the next one, it's actually the same factors, right? And so we get x plus 5 over x plus 1, but now we're plugging in 5. So we actually get 10 over 6, which is 5 over 3, 5/3. Over here, this is a really good one to factor. So in the numerator and denominator. So in the numerator, I know it's going to be 7x and x, and down here it's going to be 3x and x. So this is going to be a minus x, or minus 1 minus 1. So we have 3x squared minus 4x plus 1. So chances are there's probably going to be a minus 1 here as well. So I'm going to say minus 1 and plus 3, because now we have 7x squared minus 7x plus 3x. Yep. So the x minus 1s cancel out, and so plugging in 1, I get 10 over 2, which is 5. Over here, can't factor this. There's actually a vertical asymptote there. It's not factorable, so this does not exist. Limit does not exist. Here, yet again, cannot factor, so the limit does not. Wait a minute. Wait a minute. This is actually defined at 1. So if I plug in 1 down here, I get 1 plus 2 plus 1, which is 4. Tricky. I almost tricked myself. But here, a negative 1, that's undefined. That does not exist. We cannot factor that. Here, plugging in 3, we have the square root of, this is going to be the square root of 4, which is 2, minus 2, which is 0. So we just get 0 over 6, which is 0. Here I get the square root of 0, which is 0. Here I can factor this to be x minus 5 times x minus 4 over x minus 5. And the x minus 5s cancel, so I get 1 when I plug that in. And here I can factor this to be x minus 3 times x over x. The x's cancel out, so I get negative 3. For the asymptotes here, this we can just kind of go through this. Oh God, this is an evil one. So here, what do we got? Asymptotes at 0, that's at 0. Asymptotes at negative 2/3, the limit's at negative 2/3. Here I can break this up into the limit of 4 minus 0. So this is going to be 4. And then for the rest of these, I just have to plug in values. So this is like a billion to the 4th minus 10 is positive. A billion to the 4th a billion to the 3rd times 4 is positive, plus a billion is positive. So this is positive infinity. again, going to positive infinity. This is a positive value over, careful because this, ooh, I tricked myself again. See, I'm trying to rush. The degrees are the same. This is written out of order. So the degrees are the same, so we divide the leading coefficients. So it's going to be 3 over negative 2. So it's negative 3 over 2. Oh boy, be careful for that. And then this is a cube root. I won't have something like this on your final exam. But what we could do is we could think about what this is. This is, you know, if I plug in negative infinity here, or really you could just graph it. But here I'm just going to say that this is, well, if I graph this real quick, this is going to be x minus 3 divided by 5 minus x, all to the 1 divided by 3. And as x goes to negative infinity, it looks like we are going to a negative 1. And yeah, we divide the leading coefficients there. So that's the asymptote. So that's it. Sorry I had to rush through that at the end. If you have any questions, be sure to ask.